Okay, sorry. There's one other thing that I forgot to show you for pre-lab question one. Again, remember what we're trying to do here in pre-lab question one. We've just done what we're trying to do is find if mu is greater than or equal to 3.3 or a B plus, which means the alternative was mu is less than 3.3. So we did this sort of by hand. There is a built-in function in R called t.test. So here I'm performing a t-test. And this is really nice, but it also has some hangups. It really only works if you have raw data. So what does raw data mean? It means I have the actual individual points of all 101 people. So here you can do t.test, and then here our data was found in the file called data1 and specifically in the column called GPA. So that's where the data is. What else do I need to do? I need to tell R what the sign in the alternative. So here the command is alternative. What's the sign in the alternative hypothesis? You can see it's a less than sign. So here, the sign in the alternative, I've got the option of writing two-sided, greater, or less. So here's a lower-tailed test. So I would say the sign is the less than sign in the alternative. Here, mu, this is where you tell the computer what the value, the hypothesized value was. So here, this would be 3.3. This we'll talk a little bit later about in the course. This we'll talk a little later about in the course. And here, confidence level. This is where you can tell the computer what your confidence level and therefore what your level of significance is. So confidence level is 95 when the significance level or alpha is 5%. So if alpha is 5%, then 1 minus alpha or the confidence level is 95%. So here's a command where you can have the computer do a lot of these things for you. And so notice that it's calculated some very similar things to what we did. The test statistic we calculated to be negative 4.8, which is the same as what they did. The degree of freedom, again, was there were 101 points minus 1, which will be 100. So they've calculated same degree of freedom. And here, the p-value they've calculated here as well. Okay, so the other nice thing is it actually does give you a confidence interval if you like. Now, if you want a confidence interval the way that that we discussed it in Stat 213, then here you will have to do two-sided instead of a one-tail. So here, if you actually truly want an interval, two numbers that are bound, binding what mu can be, then you'll have to switch to a two-sided tail. And so here's a 95% confidence interval. Notice when we only had a one tail, then one of the sides of the confidence interval is actually infinity. So here, this is a built-in function. We're going to start getting more and more used to this. I think it's better, at least to start with, that we know exactly where all these numbers are coming from before we just have the computer do it for us. But here is a pre-designed function that allows R to run a hypothesis test for you.